Pre-Algebra. We are starting our last unit of the year, PO60. In fact, every objective in this unit is a PO. So be ready for the test. Make sure that you are adequately prepared.
So sorry to interrupt.
No, that's quite all right.
So for that placement test,
Yeah.
times table, can we use the times table?
No.
Okay, perfect. Hi, everybody. Sorry to interrupt.
Yeah, no calculator, no times table. It should all be.
No, you got what
mentals.
thanks.
Yeah. Yep. And the reason why they're all POs is because equations are a big part of algebra. Knowing how to manipulate terms, combine terms, distributive property, we talked about that. And so it's pretty important stuff. And we started talking about combining like terms yesterday, and we actually jumped straight into it. In fact, we did this one together. Who can look there at page and tell me what this expression, 3x plus 4x minus 9, simplifies to be? Combine those like terms. Gregory. 7x minus 9, right? We talked about whatever x is, number, tacos, right? You got 3 of them. You get 4 more of them. Total, you have 7 of them. Okay? And you can't combine the 7x and the negative 9 because the negative 9 doesn't have an x. They're not like terms. Okay? So normally we don't jump straight into the numbers. But just yesterday worked out, we did. We start with these symbols up here, okay? And it's kind of the same idea, right? If I have a soccer ball, a soccer ball, a soccer ball, a soccer ball, a basketball, a basketball, a basketball, I could say, yeah, I've got a soccer ball and another soccer ball and another soccer ball and another soccer. Or I could say what? How many soccer balls do I have? 4 of them, right? Why not just say I have 4 soccer balls? Why say I've got a soccer ball and a second one and a third one and a fourth one? Just say I've got 4 of them. Okay? And then how many basketballs are up there? 3, right? 4 soccer balls and 3 basketballs. Now I can't combine the soccer balls and the basketballs together. They're not the same thing, right? I could generalize and say I have 7 balls, period. Okay? But 4 soccer balls and 3 basketballs, they are not like terms. They cannot be combined. But they can be simplified, right? The second one, I've got some lamps, I've got some chairs, and some beds. What are the like terms here? What are the like terms here? Give me one set of like terms. Josie, the lamps, right? And how many lamps do I have? 2 of them. 2L. And when we use L for a variable, we typically use a cursive L or an italicized L, so you don't confuse it with a 1, so it's not like 21, right? You can use a capital L also, but typically that refers to liters, so we don't want to confuse that. So, but 2L, what other set of like terms do I have here? Landon? 3 beds, right? I'm going to put a box around those. 2 lamps plus 3 beds, and what's left here? Mia. 4 chairs. 1, 2, 3, 4, right? 4C. And it would be okay if you wrote those in a different order, right? If you wanted to put your beds first, and then your lamps, and then your chairs, that's totally fine, right? It doesn't make a difference what order they are in, okay? It means the same thing. You're basically explaining how many of each item you have and combining those like terms. We can't combine beds and chairs. What would that be called? A bear? A ched? It doesn't, not a thing, right? They are different things. We keep them separate. They're listed separately. So anyway, let's get some definitions because everyone likes to write down definitions, these wise old owls. A term is a part of a mathematical expression okay? A term is a part of a mathematical expression. And here's the thing that's important. So I'll write it in red so it stands out. Terms are separated by addition or subtraction. That's the big thing there. Okay, terms are separated by addition or subtraction. I'll give you an example once folks are done writing things down here. Okay. So that one we worked with yesterday, that 3x plus 4x minus 9, how many terms does that expression have? How many terms make up the expression 3x plus 4x minus 9? What do you think, Scarlett? More than 2? 3. Okay. Terms are separated by addition or subtraction. That means that 3x is one term. Then we have an addition symbol. So that separates the 3x from the 4x. 4x is a second term. And then subtraction, which also belongs to the 9, negative 9 is a third term. Right? So 3x is one term, positive 4x is a second term, negative 9 is a third term. When we combine this into 7x minus 9, we simplify it to be just two terms. We can combine 3x and 4x to make a 2-term expression here, but the original one does have 3 terms to it. Okay, a coefficient is a number written, I should say a number attached. That's a better word here. A number attached to a variable. And what the coefficient does, this is the important part, we'll do it in red. A coefficient tells you how many of the variable you have. Okay? A coefficient is a number attached to a variable, and what it does is it tells you how many of that variable you have. We talked about that down here, right? 3 x's, 4 x's, 3 tacos, 4 tacos, right? That coefficient tells you how many there are, so that when you combine them, that's how we know that total we have 7. We have 3, get 4 more, total we have 7. That coefficient comes before the variable, it tells you how many of the variable you have. A constant, a number, I hear giggling in the back. I can fix that with some movement. A constant is a number without a variable. Okay? A number without a variable. It's like it's constantly alone, just like I was in high school. Oh. Yeah, let it hit you. There you go. Then you giggle. Okay. So in this expression here, that negative 9 would be the constant. Right? It's the number without the variable. And we cannot combine variable terms with constants because the constant doesn't have a variable. Okay? Like terms are terms with the same variable. Okay? Terms with the same variable. Such as 3x and 4x. They both have an x. Right? And what we can do with like terms is we can simplify them. So to simplify is to combine like terms. Okay? To combine like terms. Like we did with that 3x and that 4x. We combine them to make 7x. Okay? Any questions on this? Okay. So go ahead and see if you can correctly combine the like terms in the second expression here. Okay. And remember, constants that don't have a variable, they are like terms as well. So if they don't have a variable, they fall into the same category as having the same variable, just not having one, right? So constants are like terms that can be combined as well. So try your hand at that second expression there. What does that simplify to be? Combine those like terms. And anyone who is feeling brave, courageous, confident, wants to share their answer. Zoe!
6 plus 8n.
6 plus 8n. Well, tell me I see where the 8n comes from there. Tell me where the 6 comes from. Yeah, Zoe. Okay, so Zoe brought up a very good point here, okay? Sometimes folks would say 8n plus 16, okay? But she said, we're subtracting here, right? That 11 is being combined with a negative 5. And what is 11 minus 5? 6. Okay? So 8n plus 6 would be the correct answer. She said 6 plus 8n. Either one is correct. You can add things in any order. Okay? But that would be right. You are subtracting that 5 from the 11 because that subtraction sign belongs to the 5. Jolie, yes.
Could you also do 11 plus -5?
Ooh, 11 plus -5. That means the same thing as 11 minus 5. So yes, you would still end up with 6 though when you combine them. Okay. Good. How about the next one? 2y plus 9y plus 13 minus 13y. Okay. First of all, identify the like terms here. All those terms are the same variable. Decide what you want y to be. Whatever it is, you've got 2 of them. Then you get 9 more of them. Then you lose 13 of them. Uh-oh. Okay. What does that end up being in the end? Nolan, you've been waiting.
Negative 2y plus 13.
Well done. 2y plus 9y is 11y. Then you subtract 13. 11 minus 13 is a negative 2y. Remember, that coefficient just tells you how many y's you have. I have 2 of them, get 9 more, lose 13, negative 2. Okay? And then, of course, this 13 here, this constant, without the y, we can't combine it with our y term. There's no other constants to combine it with, so we just leave it separate. Okay? Just feel okay? Questions so far? Okay? Going down the page, we'll do 2 more together. Anybody have one they want us to do together here? Gregory?
20n minus 3x.
Okay, the one in the middle there. 20n minus 3x minus 2n plus 13 minus 5. Yowza. Let's identify some like terms first. What can we combine? What has the same variable? William.
20n and 2n.
20n
2n.
and don't forget about that sign.
Negative.
It's a negative 2n. Okay, that sign belongs to the term. So how many n's do we have total? Well, we have 2 n terms, but this one says we got 20 n's. Then we take away 2 of them. So how many n's do we have total? 18 n's. Okay. There are 2 terms with an n, yes, but remember that coefficient. How many n's do we have? 20, take away 2. What other like terms do we have in here? Landon. 13 and negative 5. What does that combine to be? Positive 13 and negative 5 make 8. Good.
Yeah.
And since it's positive 8, we're going to write plus 8. Okay? It's positive 8, so we're going to write plus 8. And then this last term here, this negative 3x, no other x terms with it. And so we're just going to write negative 3x. Right? It is a negative 3x. That sign belongs to it. So make sure you write minus 3x. Include that sign with it in your final answer. And can those things be arranged in other orders? Yes. Right? If you want to put negative 3x plus 18n plus 8, that's okay. As long as you keep the signs the same, you can write those things in any order. Okay? But it's important that the 3x is negative. It's important the 8 is positive. And the 18 is positive as well. Okay? Yeah. The last one? Okay. 4x minus 7y plus 2x minus 9 minus 3x plus 13y. Why don't you all try it first? Okay? Identify those pairs of like terms. There are a few of them. Okay? And then see what you come up with. And then we'll do it together. does 4x combine with? What does negative 7y combine with? Anything go with the negative 9? Or is it just constantly yellow? Just like Hamilton. All right,
Wait, which one?
we're on the last one.
Oh.
Yeah. What can this 4x combine with? Josie, the positive 2x and the negative 3x. You have 4 of something, you gain 2, you lose 3. At the end of the day, how many x's do you have? Gregory? 3, right? 4 plus 2 is 6, minus 3, 3x. And then how about that negative 7y? Anything combined with a negative 7y? The 13y. Okay, I'll do it in red here. Negative 7y and 13y. What are those combined to be?
20y. Right?
Not 20y.
Oh, it's negative.
It's a negative 7y. Yep. Don't lose those signs. Okay. Don't lose those signs. How many y's do we have in all? 6. Negative 7 plus 13. Or you can flip it around. 13 minus 7. Either way, positive 6y. Okay. That coefficient is how many y's you have. You have negative 7. You get 13. Totally have positive 6. So this goes all the way back to like what? PO3? PO8, where we added and subtracted those negative numbers. Okay? It's coming back. And then how about that negative 9? Anything left?
Minus 9, please.
Nothing. So it can't combine with anything. And so it is going to be a minus 9. All right. Questions on this part of it? Okay. The next part. We previewed this yesterday, and then Mr. Olson came in and gave a masterful lesson with math unicorns and other things of the like. Okay. Basically, to remind us what's happening here, we are multiplying a quantity by a number. Okay. And so his leaping math unicorns here, as he described them, that 10 goes into the parentheses, and you're multiplying each term in the parentheses by what's on the outside. Okay? The rules change with multiplication compared with addition when it comes to like terms. If this was 10 plus n, could we combine that? 10 plus n? No, because they're not like terms. But with multiplication, 10 times n, we can do that. It's just 10 times n. Okay? And then 10 times 5, positive 50. It's kind of like the rules for fractions. Are the rules for multiplying fractions different than adding them? Yeah, right? With adding fractions, you need those things called common denominators. You need them when you multiply. You do not, right? The rules are just a little bit different, okay? But we can't combine 10 and 50 because now we are adding, and 10 and 50 are not like terms, okay? I think you left off yesterday with this one here. He said I was being a little bit tricky. Okay? We have 6 groups of 2n here, or 6 times 2n. What is 6 times 2n? You have 2 n's, and you multiply that by 6. How many n's do you have in all? Zoe? 12 n's. And then 6 times a negative 4, don't forget about that sign. 6 times negative 4 is what? Negative 24. And so 12n minus 24 is going to be your answer for that one. Okay? 12n minus 24. Pick another one in that section. One of the remaining 5. What do you want to do together? Yeah. Oh, yeah. That one is a bit of a doozy. Actually, you know what? Yeah, no, let's, I wanted that one.
Which one? 2n plus 8?
Yeah, let's try it. Try, okay? 2n plus 8 times negative 2n minus 7. Now, you see those parentheses? Those parentheses tell you you're going to need to distribute in. But the question is, what do you distribute into the parentheses? Do you distribute the 2n? Do you distribute the 8? Do you combine 2n and 8 to get 10n and distribute the 10n? what are you putting into the parentheses there? And the answer to that question is what is being multiplied by the parentheses. That says 2n plus 8 times negative 2n minus 7. What is being multiplied by the parentheses? Is it the 2n? It is not. Remember, addition separates terms, right? The only thing you're going to be distributing into these parentheses is the positive 8. And so when you distribute the positive 8 into the parentheses, the 2n out in front just kind of chilling out there. Okay? It just kind of drops down. We'll deal with it later on. And when you distribute the 8 into the parentheses, what do we get?
Negative 16.
8 times negative 2n is a negative 16n. Don't forget about that sign. And then 8 times negative 7 gives us,
Negative 56.
Gregory? Negative 56. Okay? We can also go to the order of operations for this. We have to multiply before we add. So we have to distribute the 8 in, that's the multiplication, before we do the addition, which is adding that 2n, which changes to subtraction because of the positive 8 times negative 2n there. And now we've gotten rid of the parentheses. Now we can look at what can we combine. Do we have any like terms here? Let's get someone we haven't heard from yet. Do we have any like terms here? Yeah. Where are they?
2 and the 16.
The 2n and the
16.
the negative 16n. That sign must be included. We can't forget about that sign. And if you have 2 n's and you subtract 16 of them, how many n's do you have? 2 minus 16. Someone new perhaps.
14.
2 minus 16.
Negative 14.
Negative 14. Negative 14n and then minus 56. Can't combine with anything else, so tagging along. Okay? This skill of being able to simplify something is going to be very, very prevalent in algebra next year. So we're going to spend a fair amount of time on it. It's worth it. Okay? I want you to practice over the weekend. Tomorrow's going to be a retake day. So I want you to practice over the weekend. Your homework is the previous page, anything that we didn't do there, and just this section here. Don't do this one yet. We will do it, so don't don't cross everything out, right? We will do it eventually, but not for Monday. Okay? For Monday, the previous page, finish that, and this top section, practicing that distributive property with these questions here. Okay? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Thank you. Thank you. Thank you.